Okay. Murli sir, am I audible?
Yes, sir.
Am I audible, no? Okay.
Yes, sir.
So good morning, everyone. Once again, welcome to all of you. So before going to start this session, let me introduce our today's speaker, Professor Rajesh Ingle. Is a professor at Department of Computer Science and Engineering, International Institute of Information Technology, Naya Raipur, Chhattisgarh, India. He has worked as a professor, dean, head, Department of Computer Engineering at Pune University. He has worked as an adjunct professor at Department of Computer Engineering, Government College of Engineering, Pune. He has also served as a Senate member of Savitribai Phule Pune University and head EDC and Business Incubation Center. He has also received 2014 IEEE Outstanding Branch Counselor Award from IEEE USA. He is also recipient of 2019 IEEE Region 10 Outstanding Volunteer Award in recognition of outstanding contribution and services to IEEE Pune section and IEEE Region 10. He has received a PhD degree, Computer Science and Engineering from Department of Computer Science and Engineering, Indian Institute of Technology, Bombay, Mumbai. He has received the BE Computer Engineering from University of Pune and ME Computer Engineering from Government College of Engineering, Pune. He has also received the MS Software System from WITS Planning, India in 1994. He is a senior member of IEEE Communication Society, IEEE Computer Society. He has worked as a chairman, IEEE Art and Student Activities Committee since 2015 to 2018. He is also working as a vice chair, IEEE India Council. He has worked as a branch counselor of IEEE Student Branch and president of PICT Alumni Association. He is also associated with Symbiosis University and other research center. He has worked on and associated with various BOS in IT and CSC in different universities, including Pune University, Shivaji University. He has organized a number of international conferences and meetings in various countries, including Japan, USA, Hong Kong, Malaysia, Netherlands, Sri Lanka, and Australia. He has guided more than 600 projects at UG and PG level. 5 students working with him completed PhD in computer engineering, and 4 students are working with him for doctoral research. He has more than 65 research publications at various conferences and journals of national and international reputed. So that was the brief introduction about Professor. Now I will hand over this session to Sir. Sir, now you can proceed. Thank you.
Thank you, Dr. Ali, for this, over length introduction. And thank you very much for this opportunity to interact with the participants of this workshop. So I think maybe 1 hour and 40 minutes, I'll just plan for it. And then we may have more interaction or QA on it. I hope that sounds good.
Yes, sir. Yes, sir.
Yeah. So I've already seen the speakers and the topics covered till today, and it's been, I think it's been a very good experience for you all as a participants. But today I think I'm taking you to a little bit near future, that what is happening and what is going to happen, and that I'm talking about today. I'm talking about future of network security. And that actually I'm telling how actually this SASE, we normally call it as a SASE, Secure Access Service Age, and how things will proceed further. So please let me know if there are any questions and otherwise as well. So we will actually look at first the trends, then why SASE, the trends, then computing paradigm shift, and where does this SASE actually fits in, and why are we talking about SASE now and why not earlier. Then threats and safeguard matrix from NIST, you must have come across during last few days discussion with few of the speakers. So I might summarize that in one slide and give you some information about it. Then in cloud computing also, I see one speaker has covered that. So what is the security perimeter and how actually that perimeter is used in concept is used in SASE. So I might use that 5-6 minutes on security parameter concept. Then we will talk about challenges with the existing cloud security platform and why actually SASE fits in and why SASE is required in that. So this is how today actually we will spend some time and then we will discuss more on it. So first of all, those of you who are in security must have seen this in the William Starling's book also mentions it. And I think in the security, this is what principle we follow, that we should not rely on something not happening. The question is, are we ready if it happens? That exactly is actually told here in this. I'll just change it. Yeah. So it tells very clearly that you should not rely on likelihood of enemy not coming. So whenever there are any vulnerabilities or attack, you should not rely on that somebody will not explore that, but our readiness to receive him or receive that particular attack. So not on the chance of he's not attacking, but rather on the fact that we have made our positions inaccessible. So we should be ready for all type of things. That is what is the first message from the Art of War, the story or the book or the magazine. Okay, so with this, in fact, today what we will cover up, as I said, the main focus is this SASE. So for SASE, whatever prerequisites are there, as I told you, the trends, edge computing, then computing paradigm shift. I will first cover that, and then I will tell you how SASE is relevant on top of that. So the questions when we are dealing with SASE, we have to deal with more this sub topic and sub questions over here. That why? Because we have seen cloud, mobile, and IoT. And why these have actually businesses rethinking network security architectures. So why we need to go for the new architecture and what is that actually? So we will see that. So we will look at cloud and IoT and mobile majorly you are probably have covered and known. So I will just go for superficially in the interest of time. Then what SASE is? So I'll just introduce that to you and why it is a very important topic in been discussed and why I'm talking about it. And why SASE consistently enables a rich set of integrated network security services. So whatever new business models you see, Palo Alto or maybe whatever security names you take and you check, they'll be working in one of the thing what actually we compose SASE out of these different technologies, maybe GTA, SDP, zero test architecture and all. So you must have come across few of this in last few days. But I'll tell you how actually SASE is combining all this to give a different service. Best practices to effectively secure digital business transformation. So these are a few things we need to focus on and which I think I'll try to focus my today's discussion on this. So before we go further, why secure access service edge is important. So there are three important things, and at the end of the today's discussion, I will elaborate in more details. But I'm just telling you very clearly, I can cite the motivation, three things: reduce IT cost and complexity. That itself is enough motivation for any organization to move towards SASE. Reduce IT cost and complexity. Second is it delivers a great user experience. The user experience is also improving. That is the additional benefit to have more customers and more users on your system. And the third one is that it reduces the risk. So these are the three important drivers what actually you should be going ahead. So this is 1 second. Okay, so this I think at the end I'll cover in little more details, maybe 1 hour or 30 minutes. So we will come to this slide and I'll discuss 1, 2, 3 in more details. Once you know what is inside the SASE prerequisite, probably you will appreciate why secure access services is more important. But let's get going from this point. What is driving for this? We have seen on the left hand side of this, in the changing world today, we see more devices online, right? And when you say devices online, today, if I ask you, what is the population on planet Earth? So it is about 7.6 plus something, right? Billion persons on the planet Earth today. But if you see the devices are into n number of times than that. And 2 or 3 years back, only the number of devices are more than the population on this planet Earth, the human population. So we know clearly that there are more devices online, right? I'm sorry. And these devices are actually generating more data. And that is the reason, in fact, that is a driving for IoT. And in fact, the IoT is also driving edge computing. And in fact, we are talking about the need for SASE as well from that. These are all connected and cascading effect is there for all these different emerging trends and technologies. And that is a one thing which I'll first cover, and then we'll go for the SASE part of it. So if you see the devices are generating more data, then we have seen machine learning is in the mainstream, because in 91, 92, we have seen AI, artificial intelligence and other thing was more about theory. But today it is a reality, and we see most of us are trying to do something at back end, maybe AI, ML, DL. And here also we have got the trace of it. When you talk about age, we talk about age learning, right? Just give me a 1 sec. Yeah, so let's get going on this. So we do have, in fact, you can add few more things in it also. But if you see the sensors, earlier was very costly, now it is cheaper sensors, and not just cheaper, but their size is also small and more effective and efficient one. Then increased demand for low latency is very important driving force for edge computing, and hence in SASE as well. And data privacy regulations are also there. These are few trends what I could mention here, but in addition to it, if you would like to see, we can say that networking is everywhere, computing is everywhere, right? Because we have seen various of these protocols. Maybe it is WAN protocol, LAN protocol, or personal area network or body area network protocols. All different protocols are multiple. The metropolitan area network protocols like WiMAX. Right? There are different protocols available, and networking is everywhere for every different requirements. So do the computing. So starting from your large computers, laptops, PDAs, up to the plug computer. And I hope you must have heard about plug computers also. So those who have studied computer network and seen the recent even textbook, even in Andrew Tannenbaum's book, you can see the mention of plug computer, right? So it has come such tiny and invisible computers that it goes inside your plug, and then it does a lot of work for you. And they are intelligence. So you may expect a computing to happen in that small sockets as well. So networking is everywhere, computing is everywhere, and mobility of the persons, mobility of the content. So these are all very important observations what we have seen. And this has been happening. And actually, if you look at the networking and computing, itself, the first two things, there is always a trade-off between it. Because if you talk about computing cost and communication cost, always when you try to implement some solution or give some solution, you will always look at maybe reducing the number of messages at the cost of doing more computation. If the computation cost is costlier than the communication cost, or else you will try to do less computation and have more messages. That means you are increasing the communication cost by actually reducing the computation cost. So always there is a trade-off, and it depends on the cost and how it is evolving. And there is always a trade-off in that. And when you look at mobility, whenever you move along or whatever you see, the moment you press some query, you get the answer how fast you can see that. And just compare with the latency, physical latency in the medium, then you will realize that something which is 10,000 kilometers away, you cannot get the response so fast. But how are you getting it? So whatever you things you do, there is a long peer group of running servers at the backend. Normally we see an access network. So the backend network actually deals with that, and there are hundreds and thousands of servers in the backend which actually serving you. And there are mirroring, there are various other ways of looking after serving the customer. So you get a service as if it is just available in the next door. So that is how the system works. And just imagine that when you move from one place to another place, normally the content is maintained in the local replica, and then the local server, and the replica is maintained at the remote places. And the local replica actually serves the local database actually serves you. But when you move, or when the system is the persons are moving, or the devices are also moving with you, and in the long run, even the content also get migrated. It's a very interesting to see that. So I'm just giving you some know-how about the trend, and I think this is sufficient at this stage. So another thing now, if you see SASE, and for that we have to look at the new reality. What is the new reality? In last few years, we have seen various things working, and we have seen, I think I'll touch upon that also in computing paradigm shift very soon in the next few slides. But what is the new reality? The new reality is that more applications live outside the data center. So earlier, what is to happen that we have got servers which is serving customers, and one server is to serve n number of customers depending on the capacity of that server. As the customers are increasing, the number of server needs to increase. And typically when we say database server, we have a data center, which is a farm of servers available there. Okay. And sensitive data is located in several cloud services. So users are connecting from everywhere. These are three realities what we have been observing in this, specifically in this last 2 years. We have seen the number of users connecting from everywhere, because we have enabled online examinations, we have enabled people working from home, and they are working from different geographical locations also. So users are connecting from everywhere. This is a new reality. And when the moment you have changed all this, the security also needs to be redesigned. The architecture need to be realigned to this new reality. We cannot go for the same legacy systems and go for it. Okay. So now we will spend some time on this computing paradigm shift. So I just few days back, I just tried to draw this and go ahead. So I'll explain you one by one till the edge computing, where we are now talking about SASE. So if you see last maybe 6 decades or so, starting from mainframe till cloud computing first, and then we will see how we have gone ahead with edge computing, right? So in the case of mainframe, in the case of mainframe, what is to happen? If you see the paradigm shift, you have typically a dumb terminal, and you have a server located at the central place, and the dumb terminal there physically connected with some connections. Earlier it was RS-232C over VT100 like scenario, when I have seen that mini-frame and mainframe systems. So when you look at this mainframe, even if you say like NIT, the N will go to the server, I will go to the server, T will go to the server, and the concatenation of that to convert into the word will also happen in the server. So that's the reason it was called as dumb terminal. That means it was just reading the keystrokes and transferring that to the server. And all processing used to happen at the server. That means even the data was at the server, even the program was at the server. And I hope you are understanding that, right? So everything, even the code, your program, your code and program is similar. So data and the program both is in on the mainframe. So it was pushed onto the server only, and there were terminals using it. And whatever answers comes, it was sent back to the terminal to seen by the user. This was the era of mainframe computing, right? I'm just saying computing all these boxes. Please read it: mainframe computing, PC computing, network computing, internet computing, grid and cloud computing, and then edge computing, right? The next phase came where we actually talking about PC computing, where the desktop on everybody's desktop, the computer on everybody's desktop was the aim. So you have your own personal computer, that is PC computing. And people were very happy to do that for some time. And in the office, if there are 5-6 people, those who are having this their own computers, were privileged person to use it. But later on, they realized that they need to exchange that data, or they may need to share the same printer for printing. And they wanted to exchange data. So there was a need of connecting these PCs together. Then the network computing, the intranet actually, we should say intranet, came in where on the same location, these PCs were connected together. So we have now mainframe to PC computing, PC compute to intranet computing. And when this intranet were located at central places, like think about the banks whose branches are available at n number of places, and every branch has the intranet, or there was a need of connecting this intranet among each other. And then we have seen network of networks, that is internet. And I hope you all know very clearly what is internet. And I hope you also know the difference between internet and web and who works without other. So we all know that web sits on top of the internet, and internet can work without web, but we cannot work without the internet infrastructure. So internet is one thing, which is network of networks, and that was a computing era. Now after that, in addition to that data center thing, here I'm talking about mainly the high performance computing requirement. In the high performance computing requirement, what typically happened that individual organizations have their very high HPC facilities, and the utilization was very less. And when they needed it, always they needed a more number of nodes in their high performance computing nodes. It's like, if they talk about TIFR, CDAC, or maybe any other such organizations in our country. So what they decided, like, can we actually connect it and start distributing the load among all this and utilize it and get a more power. So that's where the high performance computing requirement resulted into the grid computing, where the job was distributed and the virtual organization concepts came in. Like the virtual organization concepts came in, and there are other things also, like security, local security and the global security. It's also interesting to see the grid security part. And those of you are interested may look at it as well. Like when you talk about n number of organizations like TIFR, CDAC, and maybe the research organizations are DRDO, ISRO coming together and sharing their resources, think about each of these organizations are different, right? And there may be some private companies coming forward and you allow them. So their requirements are different. Their security systems are different. Their operating systems, network configuration is also different. So the administrative domain is different. So different administrative domain will come together with different security, security solutions. Now, when you talk about virtual organization, which is using the resources from all these organizations, the resources is pulled up into the virtual organization. Even the users are pulled up into the virtual organization. And then you have to map that local to the global, including their local ID to the global ID, and then the credential local to the global. And another important thing is there is a dynamics of it. Like TIFR may say that I will give this 2,500 nodes for so many hours or so many days. And when the processing is happening on that, it may so happen that few of the nodes need to be pulled out of from that. So we also talked about computation migration, and which is actually resolved a little bit in the cloud, in the cloud computing. But in case of grid computing, typically it was about high performance computing, and the migration of the computation was a major issue over there. So I'm just telling you the security, establishing security and resource booker was very important in case of grid computing as well. Then we actually came to the cloud computing. So in case of cloud computing, typically we initially, I remember in 2007 or so, we used to call it as the elastic computing. So scaling up and scaling down. So scaling up and scaling down, we are talking about mainly a scalability. When we talk about scaling up and scaling down, we are talking about elasticity. That means elasticity can be applied at various places, including the infrastructure as a service. So now if you take the example of number of machines in the data center, if I got 10,000 machines in the data center, and at times if I need suppose 30,000 machines out of that, of course I'm imagining right now suppose if I say the physical 10,000 nodes, machines, physical machines are 10,000, and virtually it may be n times than that, because each machine will have n number of virtual machines sitting on top of that. So you may think of actual physical machine 10,000, and out of that you may use 3,000 right now. And then as in it is needed, you can actually expand. So you may not power up all the machines. You can power up next 1,000 machines. And then as it goes, you can actually scale up and scale down as per the requirement. That actually will reduce a lot of actual cost to the giving power to the machines. Then because of the power, even the cooling, even licenses and whatnot. So there are so many other things you can scale up, and as the number of users and the utilization is reduced, you can actually shift back. So I'm just giving one example of elasticity in case of cloud computing. Okay, so so far so good. It was good. So what was the issue, and why actually we need to go for the new paradigm, the new computing paradigm over here? So in this case, what are the disadvantages of there are very big advantages of the cloud computing. We talk about the very important characteristics like multi-tenancy, elasticity. Like this, we have already seen an utilization of the resources that we have already seen, right? And we also know that you can compare that cloud computing with the mainframe also. And what is the difference and what is the similarity? If you see the similarity, I can tell you that in case of cloud also, we are pushing the data and the code or the program inside the cloud. So do in mainframe also, we used to push the data and the program which is operating on that in the mainframe. So is it the same model, or what is the difference? The difference is there, obviously, right? Because in case of mainframe, we had a dumb terminal where there was no processing done. However, today, your normal machine, a normal handheld device or the mobile are equally capable of doing a lot of processing, as it was probably to the level of mainframe in earlier 60 years before. So there is a lot of processing possible. So local processing is possible in case of cloud computing, and you can rely on that. And second is that in case of mainframe, we had limited computation facility, but in case of cloud, you have infinite capacity over there, right? In case of cloud computing, you have infinite capacity. That means you can expect the number of nodes and the devices connected to the internet. You can go up to that, right? Scale up. So that is what is the major difference between cloud computing and mainframe. And it is interesting to see, and I leave it to you. See, there are few things which were discontinued and again continued. For example, check for the virtualization, right? And then you will get the answer for it. However, now let's switch quickly to the cloud computing drawbacks. So what we have is latency is a big issue in case of current cloud because of the number of devices, number of users, and the kind of data getting generated. And there is a lot of hops, actually, number of hops you need to actually pass before you storing that. So latency is a very important thing over here. Then variation in latency or variation in delay, that is jitter, is also important. Location unawareness is an issue. Then insecure data, outsourcing, limited access, like that. There are bottlenecks in case of cloud computing, and that is the reason we actually talking about edge computing. And there are different models of edge computing. There are still discussions on that, which is a subset and which is a superset of this. But mainly it talks about the similar concept of edge computing, that is fog computing, mobile edge computing, and cloudlets. So you may actually check that and learn more about it. So let's quickly go to the edge computing part of it. The origins of edge computing lie in content delivery network. Now on the right hand side, you can just see the single server distribution. You can just check that there are 5 users and 1 server serving that. So in case of the same data is shared, actually a content is being shared in the 5 different users, but they have to go deep inside the cloud to use it, right? And so in fact, these content delivery networks were created in the late 1990s to serve web and video content from edge servers that were deployed close to the users. So that you can see on the right hand side, which is content CDN scheme for distribution. So here you can just see these are there are replica of the same data is available all 5 places, but close to the or each user now, or maybe the set of users, right? It may not be possible to create a replica per user, but per set of users it may be possible, and then you can get it. So this is a very clear indication towards edge computing, and the concept we have already seen. And then after that, in late 1919 it was done, but in the early 2000 these networks evolved to host applications and application components at the edge servers, resulting in the first commercial edge computing services that hosted applications such as dealer locations, locators, shopping carts, real-time data aggregators, and ad insertion engines. So this was done over here. This is just an to understand the edge computing. So what are the different applications and what is the need for it? Why do we need the edge computing? The one clear thing is that all application which requires less latency. In fact, I should say that there are a set of application which cannot be, they are not feasible without the latency guarantee, right? So application that cannot tolerate latency. So latency can be the reason for failure in healthcare, financial transactions, and self-driving vehicles. So they need to take, you cannot have the lag in taking decision when you're driving on road at 120 km/h, and then you are expecting some decision to be taken. Then of course, by that time, the vehicle will actually proceed further from that time T0 to the delta time. The delta time should be tolerable. So financial transactions, healthcare, and self-driving vehicles, the latency cannot be the reason for failure, right? So this is what we are having it. Then application that require autonomy. So completing task with no or minimal human interactions. So you have self-driving cars, industry 4.0. So first, second, third, and now in fourth, you talk about cyber physical system. There is a complete loop, right? Sensing to the actuation. So there is a complete loop. So we talk about first mechanizations and steam power. In the second, we talk about, mass production, assembly line, electricity, computer and automation. But in case of fourth, we are talking about cyber physical system. So they require an autonomy. So whatever sense, then what actuation to be taken. You may not have the, human intervention is required over there. And you can take the decision, and there is growing machine-to-machine communication, like self-driving car, industry 4.0. So these are the things where you need edge computing. Then applications that require significant bandwidth. Now, generate significant amount of bandwidth, like in case of smart homes, smart surveillance system, they need to identify the object. They need to identify the person. They need to identify the subject and object both. So I'm just giving these three different class of applications that require, that is a need for an edge computing. If you have any question, please feel free to ask. Okay. Then, or else you can just keep posting that, and I will answer it at the end of it. Then that all these three setup, I can go ahead with a lot of other examples, but from the above points, it is obvious that ingesting data to a distance cloud isn't a realistic option. What do you mean by that? I just talked about content delivery network, right? What was a need? So when you push some data inside the cloud, the latency get added into it. And that is the major driving force for edge computing. So what is edge computing? Edge computing is all a matter of location. Edge computing is distributed computing paradigm. This brings, in fact, computation and data storage closer to the source of the data, wherever it is generated. It is available there and there itself, so that the closed loop is possible and you have less latency, right? And the amount of data moving is also very large. I'll come to that slide also. How much data? Think about it, how much data is you're using 3 years back, 2 years back, and today. And what laws drives it? Think about it. Maybe today I will not cover that laws, like what you talk about Moore's law. So number of transistor, per that area. Similarly, the Metcalfe's law for in case of the value of the network. Like that, the law as an ICT you should be knowing, and you should actually look at that. So the critical data processing occurs at the data source rather than in the centralized cloud-based location. So it is a computing paradigm where computation is performed mostly on the power constrained devices, right? It is not inside the very comfortable place where you have got a lot of computations and storage. Actually, it is happening at the edge, and where actually think about IoT device. Think about the router, think about like this, anything which is on the edge. Now, what is an edge also in the question can be asked, and I'll actually discuss about it, right? Edge means different thing at different places and use cases. So with limited processing capability or on-premise data centers. So what is an idea? Idea is to push applications data and computing power to the edge of the internet in close proximity to mobile devices, sensors, and end users. So rather than transmitting raw data to a central data center for processing and analysis, that works is instead performed where the data is actually generated. And it actually does not depend much on the infrastructure. It loosely depends on it, because mainly it happens at the edge and the storage of that. Now, when it requires to offload and store it somewhere, like in the mobile, like we are actually having a cloud subscription. So we use cloud to store, like whatever our on mobile also we are using it for our normal other things. We are or on our laptop also we are using different cloud solutions to store, that is for backup. But for normal uses, we use our local data. So edge system also loosely depend on, and that is also one driving force you can look at. The edge system only loosely depends on the large scale cloud computing resources as needed. And that is mainly for offloading, computational offloading. Sometimes the computation or storage needs to be done at other place. Then you offload there and get the answers from. Okay. So the world's data, if you look at, expected to grow 175 gigabytes by 2025. And this is from the Gartner's thing, and different people will give little bit variation in it, but it is amount to the, and you all can check that the world supercomputer computational capacity, you can just check. It is actually, you can just match with the data, how much data is actually available, and then what the capacity of the supercomputing facility available at any institute or the nation. The increase of IoT devices at the edge of the network is producing a massive amount of data. Storing and using all that data in cloud data center pushes the network bandwidth requirement to the limit. And it's not just storage, but even the network bandwidth also is used in that. And there is a constraint in that, because a lot of data is being sent from user to the cloud. So on the left hand side, you can see there is an edge node in between. So it passes through that. So instead of storing into the deep inside the cloud, you can store it on the edge and use it over there. So despite the improvements of the network technology, data centers cannot guarantee acceptable transfer rates and response time, which however often is critical requirement for the many applications. And devices at the edge constantly consume data. So at the edge, whatever devices are there, they actually constantly consume data and start using it. So actually that is what companies are looking at, to decentralize data storage and service provisioning, leveraging physical proximity to the end user. When you know that you can serve from the device which you already deployed near to the user, right? You can put some intelligence and the services there and serve the customer there itself. So that is what is the driving force in case of edge computing. So in here, the aim of edge computing is to move the computation away from the data center, right, towards the edge of the network, which is near to the user. And that is actually exploiting smart objects, smartphones, network gateways to perform tasks and provide services on behalf of the cloud. By moving services to the edge, it is possible to provide content caching, service delivery, persistent data storage, and IoT management, resulting in better response time and transfer rates. Now, these are all advantages we are talking about. at the same time, distributing the logic to different network nodes, introducing new issues and challenges. And that also needs to be addressed. So the question may be asked, what is an age? Now, it is highly dependent on the use cases, as I have already said. Depending on the use cases, what is on the age, then you can decide and then go ahead. So it is highly dependent on use cases, as we said. So in case of telecommunication, it may be the cell phone or the cell tower. In automobile example, it could be a car. In manufacturing, it could be a machine. And the information technology field, it could be a laptop. So depending on the use cases, the age will differ. And actually that is where your intelligence and your processing, your data majorly will lie. And the customer will get lower latency by doing so. So edge devices are the devices like machines, sensors, through which the data is collected and delivered. Now here, I think this may probably our last slide about edge computing explanation here. So if you see, you can just check very clearly that the video analytics from there, if you would like to store deep inside the internet, how much latency is required for storing and fetching it. So the reduced latency through the edge computing is shown at the middle of this diagram. You can just see. So the network latency and then reduced latency through the edge computing, and that is what is the biggest advantage over here, that you can store this on the edge node itself and start making use of it, right? And there is a lot of opportunity for providing this edge computing devices in existing infrastructure. So in the existing infrastructure, whichever these existing things are there, only you have to provide little bit. So the micro data centers at the edge base of the cellular towers, right? And the multiple organization. So you have multi-access edge computing, open edge computing, open fog consortium, etc. And there are various business models over here. Okay. Now, just spend 2 minutes on threats and safeguard matrix of this. And I'll just take 2 minutes for you to look at this, and then we will go further. And I'm just telling very clearly that this matrix allows a company, to overlay its major threats with the NIST cybersecurity functions, and they are identify, protect, detect, response, and recover. And few of you must have seen this in last 4-5 days, like phishing, ransomware, web app attacks, and vendor the data loss actually. Okay, so just think over it. Just give me 1 minute and then I'll be back. Just spend 2 minutes on this and then we'll go further. Okay, I think this is self-explanatory, so I was not, explaining everything, but now you must have given you some information that whenever we are working on in the security domain, we may work on all these: identify, protect, detect, respond, recover, or maybe working on few of these areas. But when we talk about work in the security, of course, when we talk about security, we also need to look at the protocol stack and what layer of security your protocol stack you are working on. And even the kind of threats you are looking at: phishing, ransomware, web app attacks, and vendor and partner data loss. So maybe the endpoint detection and response, that is EDR, what you can see. So you need to first identify, then you should have ways to identify. In fact, when we talk about capability, this is a very important thing to look at. You just see in this last 2 years, we must have seen many ransomware attacks. And in fact, last 10 years, we have seen phishing attacks. And web app attack also we have seen for more than that. And the data loss recently we have seen very important because, there is a question. Can you please, if you want, you can just send, or else we'll take at the end of it. Okay. I'll leave it to the organizers for that. So identify, protect, detect, and respond and recover. So all these different things you need to work and look at. Okay, so maybe if it is needed, we will get back to this again. So in the interest of time, we will just move further for the next part on it. I just wanted to give you the glimpses of number of threats are there and number of different functions and safeguards are there in the security domain. And I'll tell you one example. Suppose there was a ransomware attack on any one of the organization. Then how it is reacted depends on the capability of that organization. Do they have a tools to identify that? Many of the organization even didn't realize that there was a ransomware attack because they do not have any system to detect that. They do not have the for protection mechanism like antivirus, endpoint protection, email security, and offline backups. Because they were not having backups, their system could not be restored. Now, if they would have had a backup, they would have started from there and only the loss would have been minimal. So even these all capabilities are very, very important. Then you need to have something for identification, protect, then detect, then what to respond, how to respond to that, and then recover from that. For every one of this attack, you need all these different functions and safeguards in place. And that actually give you the foolproof system. Okay. So far, so good. In fact, if you look at the hype cycle for cloud security, you can see last year, in fact, secure access service edge was at the top in the bell curve of the Gartner's prediction. And you can just check some other things also. We'll not spend time on discussing about other technology, right? Because I'll immediately take you to the recent one that was in 2021, because it comes in July, August. So this was in July 2021, and this year's is not yet revealed. So this is the latest one, what you can look at. You see SASE is still there here. And what do you mean by that? And if you see the color tells you very clearly that it is relevant for next 2 to 5 years to see. So that also tells you how much relevant it is and when it is going to be in the productivity. So it tells that how many years you can actually plan and monitor for it. Okay. So you may also look at similar things over here in case of security related to cloud security. And in this, SASE has a very important role to play. And that is the reason, in fact, we are talking about cloud security today. So why, before we go further, last year when we looked at the Gartners and other people's prediction, they rated this top 9 security and risk trends. The first one is extended detection and response, that is EDR capabilities emerge to improve accuracy and productivity. So extended detection and response capabilities, I'll explain you what is that. Then security process automation emerges to eliminate repetitive tasks. So security process automation also is another trend where it is been mentioned. The third one is AI creates a new security responsibilities for protecting digital business initiatives. Of course, you are all aware of this, and there are different responsibilities because of AI introduction in the security domain as well. Then the fourth one is enterprise level because a lot of things are done in silos, so you needed an officer to look after all that things together. So when I talked about that, identify, protect, detect, respond, recover, for that you needed someone to actually look after that, and in silos you could not actually do that all that things together. So another thing is like privacy is becoming a discipline of its own. It was not merely a compliance, but it was needed. Then new digital trust and safety. Teams focus on maintaining the integrity of all interactions where the customer meets the brand. So far, so good. Whenever somebody is inside the system, we were giving access to the thing. So in the real life also, if you see A is friend of B, B is friend of C, does not mean A is friend of C. So the transitivity of trust is a very important thing what we need to check in case of security. So, I hope you all in the security domain understand it very, very clearly. The seventh one is important. What we are focusing today is network security transform from the focus on LAN-based appliance model to the SASE. SASE we are calling SASE. So the next one, so we'll discuss little bit more details about it. And then just wanted to check with Dr. Ali. You are able to hear me clearly, right?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Please let me know if there is anything and we'll go further.
Yeah, sure. I'll tell you.
So full life cycle approach for protection of dynamic requirements for the cloud native application, and then GTA. So there also we see SDP, another thing happening in that domain. Okay. So maybe just 1 minute. Yeah. So when you look at this extended detection and response capability, so what do you mean by that? So in fact, you can take an example, because you may detect an attack and that causes alerts on email, endpoint, and network, because you have got 3 different solutions for it and you install it in your system. And the attack maybe causes alert on email, endpoint, and network can be combined into a single incident actually. So the primary goal of this XDR solution are to increase detection accuracy and improve security operation efficiency and productivity. So this XDR, or sometimes you may say EDR, automatically collect and correlate data from multiple security products to improve threat detection and provide an incident response capability. In fact, if you ask me, I will also recommend not just security, why not even the fault tolerance also should be integrated with the team members, because it will also be optimized one. But of course, in case of security products, it has to be. Then security processes automation emerges to eliminate repetitive tasks. So, you have a shortage of skilled security practitioners, availability of automation within the security tools. And these 2 things have driven this automation. And this automated security task can be performed much faster in a scalable way with fewer errors. So, but of course, there are some diminishing returns to building, maintaining, and automation, right? And the technology automates computer-centric security operations tasks based on predefined rules and templates. Then another trend 3 is AI creates new security responsibilities for protecting digital business initiatives. So protect AI-powered digital business system, leverage AI with packaged security product to enhance security defense and anticipate a nefarious use of AI by attackers. So, and especially ML continues to automate and augment human decision-making across the broad set of use cases and in security and digital business. So this is the third one. The fourth one is, as I said, the example of ransomware attack. The organization primarily focused on information security centric efforts and are not equipped for deal with the effect of security failures on the physical safety. And that is the reason, in fact, they needed to have an integrated solution to that, right? So the potential severe attacks on the building management system, GPS spoofing, and continuous operational technology or Internet of Things system vulnerabilities straddle the cyber physical world. And that is how in fact, it is needed to looked into by the one resource So the resource can actually aggregate IT security, OT security, physical security, supply chain security, product management security, and health, safety, and environmental programs into a centralized organization and governance model. Now, this is what is a trend number 4. And fifth is privacy is becoming a discipline of its own, right? So it is not just part of the compliance, but it is an requirement. And as a rapidly growing standalone discipline, privacy needs to be more integrated throughout the organization, right? And privacy discipline co-directs the corporate strategy, and as such needs to closely align with security. So IT, OT, IoT, procurement, HR, and legal, and many other things as per the requirement. So compliance is that. The next is digital trust and safety, right? Security for this, there are actually customer normally interact with our system through touch points, and we need to actually secure consumer accordingly. And security for this touch point is often managed by discrete groups with specific business units focusing on areas they run. So we cannot rely on that, because if I'm an organization and then if I'm taking services, security services from 6 different vendors, all of them have their own different working. And then if I want as a customer a unified thing, may not be available to me. Like in case of ransomware attack, I just go to antivirus people, like what is their log, give me, then endpoint security, give me, or maybe some other thing what I have. So I need to talk to multiple vendors for that. So however, companies are increasingly moving towards cross-functional trust and safety teams to oversee all the interactions, ensuring a standard level of safety across each space when the consumer interact with the businesses. Network security transformed from the focus on LAN-based appliance model to SASE. Now, this is what our focus. So we will see in next slides what are the disadvantages and why actually the cloud existing things is not able to give the solution. So cloud delivery security services are growing increasingly popular with the evolution of remote office technology. And we have seen that in last 2 years very exhaustively, 2.5 years to be very precise. So the SASE technology allows organization to better protect mobile workers and cloud appliance applications by routing traffic through a cloud-based security stack and not actually backhauling the traffic, right? So it flows through a physical system security in a data center, right? And I'll explain in more details in the next few slides. So we will have a more detailed treatment. Another trend is a full life cycle approach for protection of the dynamic requirement of cloud native applications, right? And this is also one thing which actually required. So this leads to the development of cloud workload protection, right? And combining this CWP with emerging cloud security posture management accounts for all evaluation in the security needs so far, so good. Then the last one in this is GTNA, Zero Trust Network Access Technology. And with this, many of you might have heard of SDP. That is, the another thing, like let's not go into more details about software-defined perimeter and other technologies. So with this, SDP also has been talked about. But Zero Trust name itself tells that subject and object needs to authenticate and authorize each other for every access, right? And not just once it is there, then you go on using it. So it's very important to see this emerging GTNA, which enables enterprises to control remote access to specific applications. And this is more secure option as it hides application from internet. GTNA only communicates to the GTNA service provider and can only be accessed via the GTNA provider's cloud service. And it reduces the risk an attacker piggybacking on VPN connection to attack other applications. And full-scale GTNA adoption does require enterprise to have an accurate mapping to which user needs what access. Of course, because the security, when you say what is the cost of adding this security, of course, there is a cost of it. You cannot get security by saying that, actually the existing system cost is reduced because of the security. No, because you are adding additional functionality and it will have some cost of doing so. Okay, now what is the problem of network security? So the problem of network security is, we all know, right? The internet allows an attacker to attack from anywhere, right? The attacker can attack from anywhere knowing just one vulnerability. However, we as a security analyst need to close every vulnerability. And that is where the challenge is, right? Even if in a system they know one vulnerability, it is sufficient for that to attack. And similarly, even if you have, close 99 vulnerability out of 100, you are still getting attacked. So that is how the problem is there, that you need to do more work than the attacker. And that is how actually the problem is faced over there. And threats are actually continue to evolve. We have seen from 85 till 2005 till now 2022, the motivation initially was just an curiosity, but today it is going towards financial and criminal, if you see an x-axis. And the timing also, you can just check how it is growing, and the motivation is something which is worrisome, right? And this is what we need to look at, and continuous are it's still evolving. Now I'll take just 1 minute to tell you. Let's see. I'm just giving one example, and not necessarily this is the only one. Probably you can search other examples for proving this statement that encryption is less secure than we thought. I'll tell you one example. Okay, so this is one in 2013 August. And the title is also, you can see at the bottom, the link also says encryption is less secure than we thought. Even if you search, you will get an article on this, right? And those of you who are having it, you can just search for it. So, and this is typically, and this article refers to the information theory, the discipline that gives us digital communication and data compression. Also put cryptography on a secure mathematical foundation, right? And most this information theoretic analysis of secure schemes have dependent on a common assumption, and they have some assumptions, but unfortunately the assumptions may not be correct. And here we have seen that one assumption is turned out to be wrong. For 65 years, most information theoretic analysis have made mathematical assumption that turn out to be wrong, and it is proved by this one of the paper, and this both links I am just mentioned at the source, and you can just check that. And maybe you can check the MIT the professor's name, and she was explaining it. You can just see on right hand side, and you can just check what it is. But what problem actually she explained over here is the information theoretic analysis of the secure systems have generally used the wrong notion of entropy. And you all know what is entropy, right? So, so it relies on the Shannon's entropy. You all know, like if I got two files and the entropy of both the files, if it is the same content, then the file with less size is having more entropy. So if I use the compression, then and without not lossless compression, then actually the smaller size file will have a larger entropy. So I hope you get that. So the Shannon's entropy was used, and Shannon entropy actually is based on average probability that a given string of bits will occur in a particular type of digital file in a general purpose communication system. That's right type of entropy to be used, because the characteristics of the data traffic will quickly converge to the statistical averages. But in case of cryptography, the real concern isn't with the average case, but with the worst case. And the moment you see that, you actually, when you're changing from average case to the, or worst case to the average case, you have introduced the vulnerability in that. And as you said, even if the adversary or the code breaker could exploit that, you're done, right? That is how actually. So whenever we talk about assumptions, there needs to be looked into. Or else I'll just tell you the example. I think few of you definitely know two-party Diffie-Hellman. Now, two-party Diffie-Hellman have given some proofs, but under that there is an assumption that when you say alpha raised to n1 mod p, the alpha and p are prime numbers. And if you use any random two prime numbers, will not work there, because there is a relationship between alpha and p. Alpha is prime root of p. And if that assumption is not maintained, you cannot expect the security to be provided. Otherwise, your algorithm can be broken within no time. I hope you are getting it. So the assumptions are very, very important. The algorithms are there, but in that algorithm, what assumptions are there, you need to look at that. And I'm giving you two examples right now. Okay, so be alert on that and be very, critically analyze the things and what you're using, and then go further. Okay, so another thing is that when we talked about all this, age learning tells that there is something happening at the age, right? And then introduction of machine learning at the age devices is, we are calling that as an age learning. And there is, of course, today we are not talking about age learning in much depth, but because it is in required for the completeness, so I'm just telling you that there is a age learning. Then whatever thing what we use for machine learning, right? So there are APIs, libraries, platforms for age learning, right? And the question may be asked, which one is the best? Of course, it depends on many factors, right? About your age learning application. So use cases are very, very important, because we have already seen that from cloud intelligence to age intelligence. This is what I'm indicating for last few slides, that we are moving from cloud intelligence to the age intelligence. And I have taken you the computing paradigm shift starting from mainframe to the edge computing. And now that I'm explaining that the intelligence is moved towards the age now. Okay, so before we go further, we need to understand this concept also of security parameter concept. So here, just give me 1 minute. You can just have a look at it. And actually, few of you must have seen this earlier. Okay, so now if you look at general cloud environment, you can check on the top left, that is client initiating the process access. So clients are initiating the access, and you can see there are cloud provider, there are few machines on and few machines off. That is what elasticity means for. Depending on the requirement, you can switch off and off the resources. And if you see, there is a dynamics in the resources, dynamics in case of users. Users are coming in and walking out. So clients are initiating access, using it, and terminating the access, going out. Similarly, the new hardware is coming in, and the existing some hardware is actually defective hardware is getting replaced. This is the general cloud environment. Then in case of, so this is the concept. Normally what we have is perimeter security. So this is a logical security and not the physical one. So concept of access boundaries to organize and characterize the different cloud deployment models. So whenever someone are inside, they have access to it because they are internal to that perimeter and have access to it. Physically, they are inside and then using it. The one who are outside will not get access. Their access will be blocked unless they are going to the boundary controller. And this is a simple concept, and I hope you understood this. And now let's try to map this to the different service and deployment models of the cloud in next 2 or 3 minutes. Okay, so now you just check here. The security perimeter extends around both the subscribers' on-site resources and the private cloud's resources. So this is actually about the on-site private cloud scenario. That means on your site, you have got your own private cloud, and you have got the users which is using it. So if you now put this inside the your perimeter, you can actually go ahead, and this is what is your security perimeter. So subscriber control security perimeter in this case, because it is on your premises. Now this is actually done by the subscriber. If anybody comes from outside, will be blocked, and if anybody comes from outside through the boundary controller, will only get access to it. The private cloud may be centralized at the single subscriber site or may be distributed over several subscriber sites. And the security perimeter will exist only if the subscriber implements it. Now, this is outsourced private cloud scenario. Now, in this case, you can check on the left-hand side, this is a cloud provider facility like Amazon or maybe another big cloud service provider. And part of their resources are actually given to the subscriber, which is actually physically at different place. And their users at the cloud subscribers facility will use it through the boundary controller and boundary controller at the provider, and then it will use that services. But others in the same premises will not have access to, right? And this is the outsourced private cloud scenario. Similarly, then you can go for a community cloud. Then I hope you have getting this. This is just an extension of the security perimeter. Now I'm just trying to tell you the complexity of security when you talk about existing cloud, right? And how actually it is getting resolved in case of SASE, right? So, and this is outsourced community cloud scenario. Okay. So I'm just leaving it for 2 minutes, and it is self-explanatory. Only the deployment and the service model combination has changed. The perimeter concept is similar, but the moment you understand for every of this cloud and service and deployment model, it differs then. And public cloud scenario, it is like this. And the hybrid cloud scenario will be something like this. Okay. So with this, in fact, I'm just telling you the perimeter concept. Now, in spite of the security challenge, if you see the challenges and the security was mentioned by 74%, then also cloud was deployed because of it cost benefit. And security was the highest rated in case of cloud. There are security issues then and now also. Okay, so now let's understand what are the challenges then, where we say 74% people said that. So what are the challenges with the cloud network access and a remote workforce? So what about cloud applications connecting to the cloud, to other cloud applications? How do we secure the network connections people create between the corporate data center and cloud environments, the corporate office and the software as a service applications and end users, right? And in fact, we have seen that it is distributed to everything. So how can we monitor all traffic between all these services and devices and keep it secure? So when you talk about monitor, just take the example of telecommunication management network like mobile phones, what we have, or earlier PSTN network. So all these network we can use, like if it is CMIP, what is used for TMN network? CMIP is used for network management protocol for telecommunication management network. And by sitting at one place, you can actually monitor by using the CMIP at every places. Similarly, in TCP/IP protocol stack, you have SNMP. Of course, SNMP v1, v2, v3, there are different versions and there are different capabilities of it. But by doing so, you will actually get to know the status, and actually you can take actions on it. So you have millions of subscribers and thousands of your routers and many places things are happening. Think about it. How will you monitor that? Okay. So challenges, these 6 things we are talking about: backhauling VPN traffic, VPN performance issues, domain name service lookup latency and other problems, internet exposed traffic, authentication and authorization challenges, and logging problems. When you want all your users to use your corporate VPN, all that traffic gets blackhauled to your corporate network, right? That is the issue with the current challenges by the cloud network access for the remote workspace. Then next is another problem is that companies suddenly have many more remote workers trying to use their corporate VPNs, and those appliances are getting overloaded. Now, some people propose a split VPN, which can help. But if you look at that, what traffic do you choose? Not to know what traffic should go through that and what traffic should not be going through this. This is going to be a challenge in that. The next is that when people are using it from different places, where will end users DNS queries end up? Those of you who have done domain name service and network, computer network, you know this question for sure. How the DNS lookup latency or other problems are there, which DNS they will use? Because at the remote place, they have their DNS, what they are using for their own network service, because they may have their own Wi-Fi, their own service provider, and actually they are using the company's resources. So which one? Will they use your corporate DNS server? The DNS server of their ISP? Or how will they access private DNS servers? That this seems to imply you need to be actually on the private network and probably need a VPN connection. Then internet exposed traffic. How much traffic will traverse the internet? And is it encrypted? So you have a question on that. Because whenever you do encryption, there is a cost of doing that. There is a latency added. There is a computation cost. There is a communication cost, because the data is more which we need to send from one end to another end. So are full packets encrypted? Or is all the traffic encrypted, or just part of it in the split tunnel or the SSL VPN scenario? How much of it is captured for inspection? How will you ensure traffic is not intercepted or redirected as users work from home? These are few things. Then how will you prevent attackers on internet from accessing private applications? When you have to allow remote workers to connect from many undefined and potentially changing locations. Because they may be, you cannot restrict them to sit at one place. They may be changing their own locations. They may be going to friend's place, maybe relative's place, or maybe a hired place. So how will you ensure the person remotely logging in is the user they claim to be? It's very difficult. And is authorized to access the application. I hope you are getting the challenges, and in the last 2 years or 2.5 years, we have already seen that. Then there are logging problems. Where you will store all this data? Will you capture all the logs from the remote workers? And can they connect to cloud services without going through your VPN or security appliances? Even the log data, when it is sent, will it be encrypted? What about cloud to cloud connections? So there are many challenges with the cloud network access and the remote workspace. And that is why, in fact, the solution for this is SASE. The solution to many cloud connectivity problems is SASE. Okay. So how does SASE fit in a security architecture? So you see that secure access service edge. So I have given you very clearly over here the statement itself. Just 1 minute. So first of all, let's figure out the definition of this new acronym and what it means. So secure means we want to make sure that what goes through this security service is safe and protected. Very clear. The word S is we want to make sure that what goes through this security service is safe and protected. Second, access indicates the ability to allow appropriate access to the original assets. The resources should be accessed. The subject should be able to get access to the resources. Subject should get access to the object. Service implies it's the service model for providing access to services or both. Now, this is the SOA principle where we talked about. So it also indicates that it may be service to service or machine to machine communication. Edge suggests that we have an endpoint on the perimeter of a network to which other devices connect. Now that's why I introduced to you edge computing, because that was a prerequisite for understanding the SASE concept. So what is the definition of SASE? The secure access service edge is an emerging offering combining comprehensive WAN capabilities with comprehensive network security functions. That is SWG, CASB, FWASS, AAS, and GTNA. Of course, I'll give details right now to support the dynamic secure access needs to be digital enterprises. So SW is Secure Web Gateway. Then CASB, you'll see many acronyms, and the moment you say SDP means something at the particular context. So please look at that, the context first. CSB Cloud Access Resource Broker, Security Broker, then Firewall as a Service, then Zero Trust Network Access. And normally the ATP will go with GTNA. Now, when you look at mainly the timeline of changing security standard, we talk about Secure Web Gateway, SWG, in 2007. Then we talk about SIG, that is Secure Internet Gateway, in 2017. And now we are talking about SASE in 2019, which is tossed by Gartner in 2019. And since then we are looking at it. So, if you look at this SWG, right? So it delivering the URL filtering, advanced threat defense, and legacy malware protection to defend users from internet-based threats and help organization enforce web security and policy compliance. And in case of SIG, especially, in fact, it is a single cloud-based solution with a greater set of capabilities than SWG. So it had the potential to replace some of the security solutions on premises, especially for organizations with distributed network or standalone software as a service offerings. So in case of 2019, we talk about SASE. Gartner predicts that SASE will become the new standard for security in coming years, with at least 40% of the enterprise adopting explicit SASE strategies by 2024. And this is actually the prediction, and we have already seen this in last 2 years. And by 2024, I hope to see this coming to reality. There may be a little bit variations here and there. So Secure Access Service Edge is a way to re-architect security connectivity and is designed to help security and risk management leaders address the changes posed by the digital transformation. So security and IT leaders can discover key use cases of SASE. 1, improved branch office and remote user connectivity. 2, simplified protection of users whenever they sit. 3, visibility and control of cloud-based apps and data. And in fact, those of you are interested may go to the Gartner's report, that is the Future of Network Security in the Cloud, August 2019. And this report is available, and you can go and look at more details. And of course, the citations of that will give more such information. SASE security connects remote users and branches to everything. And it actually, that's what now I said, it unifies, because whatever things you have seen in last 4 days, you will realize that in the future, you will see that they are under one umbrella of SASE. And it SASE unifies 11 plus different cloud security services, is built to prevent sophisticated cyber attacks, and improves the user experience through the high performance security services. So these are the 11 plus different cloud security services. What is getting covered with the SASE. Okay. What are the key findings in it? Yeah, Professor Ali, is there any other input from your side? We have some 20 minutes right now, right?
Yes, sir. Yes, sir. You can proceed, sir.
Yeah. Thank you.
No.
So, in fact, if you see the network security architectures and other things, so digital business and edge computing, these are two important things. That's the reason I covered edge computing at the beginning as a prerequisite for that. Now, very important to observation you should look at over here is that these have inverted access requirements, because there is a sudden change in the access requirements, with more users, devices, applications, services, and data located outside an enterprise than inside. Now that indicates a complete different requirement for coming out with the architecture to look at this inverted access requirements. And I hope you are getting, this is a very important key finding over here. So the complexity, latency, and the need to decrypt and inspect encrypted data traffic once will increase demand for consolidation of networking and security as a service capabilities into a cloud delivered secure access service edge. So very important over here is like what we have seen in content distribution network. SASE offering, in fact, needs a worldwide fabric of point of presence, right? So to provide low latency access to users, devices and cloud services anywhere, enterprises need SASE offering with a worldwide fabric of points of presence so that less latency is there, and peering relationship among these POPs, right? So inspecting and understanding data context will be required for applying a SASE policy. Then so far so good, we have seen the data center as the center of it, and there everything is happening. So the legacy data center as a center of the universe, network and network security architecture is absolute and has become an inhibitor to the needs of digital business. And that is the reason you need to go for the SASE. The enterprise data center is no longer the center of access requirements for users and devices, because this digital business transformation efforts and most of these platforms and emerging edge computing platforms, software as a service, these all have turned the enterprise network inside out, inverting the historical pattern. So the legacy solution needs to be re-looked into it, and that solution is given by the SASE. So digital enterprises are characterized by these 1, 2, 3, 4, 5, 6 different things. More user work perform off of the enterprise network. Second, most of the workload running in as infrastructure as a service than in the enterprise data center. More application consumed via software as a service than consumed from enterprise infrastructure. More sensitive data located outside the enterprise data center in the cloud services than inside. More user traffic destined to the public cloud services than to the enterprise data center, and more traffic from branch offices heading to a public cloud than to a enterprise data center. Now, if you see all these characteristics, you realize that the legacy solution, which was keeping data center at the focus, is no more, viable. And that is the reason, in fact, you need to look at this usage pattern and expand further with the growing enterprise need for the edge computing capabilities that are distributed and closer to the system and devices that require low latency, then local storage and compute. And if you look at now 5G, and of course 6G will also we are thinking of, so 5G acting as a catalyst to accelerate edge computing adoption, because specifically when I talk about set of application, we talked about the availability of bandwidth, the application which needs huge bandwidth, and 5G will enable that in cloud computing. That third set of applications what I given you at the beginning of this session. And those of you who are interested in knowing more about the edge computing, you may go for this Gartner.com source, Exploring the Edge, 12 Frontiers of Edge Computing. In the interest of time, I'm not covering it here right now. So the need for agility support a digital business transformation effort while keeping the complexity manageable. So there are many such things, and very important thing to see, look at this convergence of network and network security services. So if you look at network, the network examples are SD-WAN, and for example, network security services such as SWG or CSB or firewall as a service. Now there is a convergence of this happening, and that is what and now I'm going to explain in the next slide. Okay, I hope you can see this slide. Okay, here actually, if you see the SaaS convergence, you on the left hand side you can see the network as a service, and you can see on the right hand side network security as a service, right? And if you see the network as a service, you have SD-WAN, carriers, CDN, WLAN optimization, network as a service, bandwidth aggregator, and networking vendors. And on the right hand side, you can see network security, CSB, cloud, SWG, GTNA, then FWSS, right? And many other things what is been mentioned over here, right? So cloud access, security broker, and many other things, right? It depends on things. Okay. So with this, in fact, you can just see that merging, and if you see, the SASE offering will provide policy-based software-defined secure access from an infinitely tolerable network fabric. So here, in fact, you can just check that the emergence of SASE will create a significant opportunity for security and risk professionals to securely enable the dynamic access requirement of the digital transformation. And it provides actually a secure access capabilities to a variety of distributed users, locations, and cloud-based services. Okay. So in fact, it is actually reshaping the landscape over here, and you can just see this is actually a convergence of SASE. And this convergence is mentioned over here. SASE capabilities are delivered as a service based upon the identity of the entity. So identity is important, real-time context, enterprise security, compliance policy, and continuous assessment of risk trust throughout the session. Continuous, remember very clearly, and it's going to be a costly affair, right? There is a cost of doing that, right? When you send one data from point A to point B, and at every hub you do error checking and error correction, there is a cost of doing that. And if you send it directly, it will take lesser time because it's less propagation, less computation time, and less delay. So identities of the entities can be associated with people, groups. So identity need not necessarily an individual person. It may be associated with the group of people, devices, applications, services, IoT systems, or edge computing locations. And there are different SASE components. So SASE combines networking and security point solutions into one unified cloud delivery service that we have already explained in case of convergence. So in case of soft components, you can just say CASB, that is Cloud Access Security Broker, then DNS layer security, firewall as a service with intrusion prevention system. Now we are not given the example of intrusion detection system right now. We're talking about intrusion prevention system. Think about it. The moment we talk about GTNA and zero trust architecture, those of you who known snort and other thing, intrusion detection system based on signature. But now we talk about behavior, and we have gone one thing a little further about IPS. So secure web gateway, then GTNA, zero trust network access, and software defined wide area network. So these are few components which are explaining here. Typically, we have this traditional data center, right? So in the traditional enterprise network, so this actually are the architecture that places the enterprise data center at the focal point, right? For access the increasingly it is ineffective and cumbersome in the world of cloud and mobile. So even with the adoption of some cloud-based services, even if you do that, such as SWG or CDN or WF, the data center is still the center of most enterprise network and the network security architectures. So even if you get something onto the cloud, still you will not able to give the solution what you are looking for. This is a traditional data center, hub, and other things. This is a scenario. You can just check that. So in case of SASE, instead of forcing various entities traffic to inspecting engines, right, in boxes in the data center, so we are allowing them to diminish there itself. We need to invert our thinking to bring inspection engines and algorithm closest to the where the entities are located. And that is how the SASE identity centric architecture is. So in fact, so it depends on whether we are connecting users to the internal apps, cloud-based app, software as a service, or the internet in general. These all present variations of the same security access problem, right? So the branch office, if you look at a branch office, it is simply a place where multiple users are concentrated. Likewise, a salesperson in a car accessing a sales force is a branch office of one. So an IoT edge location is a branch office of the device. So we have given 3 examples of branch office, right? And then it's still mentioning, and you can just check on the left hand side. This is the internet of core backbone, then internet edge, then distributed edge, where we have got IoT edge computing locations, And then SASE consists of all these different components, and user actually accessing it, that is given in this circle over here. Okay, so all of these are the endpoints identities needing access to the network capabilities spread throughout the internet, right? And if you see in the figure, identities are on the new center of access decisions, not at the data center. So in a digital business, secure access decision must be concentrated on the identity of the entity at the source of the connection. And that is user, device, branch office, IoT device, edge computing location, and so on. That is given in this circle over here. You can see. And it's interesting to also see this SaaS stack dynamically applied based on the identity and the context. So on the left hand side, you can just see George, Sue, or the one, there are users, right? And on the right hand side, you can just see what is getting used. So the location of the entity requesting the service is on the left, and the access to the capabilities on the right hand side. And SASE delivers this required service and policy enforcement on demand. And that is independent on this location and the access to the capability. You can say the capabilities are mentioned in network and security, and they're combined together in case of SASE. Otherwise, normally we handle it separately. So in case of network, we have latency, optimization, cost, QoS, geo restriction, path selection, routing, caching, CDN. And in case of security, we have got DLP, data loss prevention, WAF, then other things, GTNA, SDP, software defined perimeter, DNS, domain name service, like this remote browser isolation, that is RBI, remote browser isolation. Okay, and privacy, network encryption, decryption. So this is a SASE stack. Okay, and one more point I wanted to just put forward is that from traditional heavy branch to cloud-centric thin branch. So the models, how it is changing. So you can look at this from heavy branch to thin branch, but with the cloud, heavy cloud support on it. And of course, those of you who are interested may look at SASE architecture reference, and from Cisco, Checkpoint, you will get many of these things, and then there is good article available on it. So in the interest of time, I may not spend time on talking about it. SASE benefits and users. SASE will enable security teams to deliver a rich set of secure network security services in the consistent and integrated manner to support the need of digital business transformation, edge computing, and workspace mobility. So the adoption of SaaS should offer the following benefits. Please have a look at it in 1 minute. Reduction in the complexity and cost. We have already told you about it, the main three. Enable new digital business scenarios. Improvement in performance latency. Ease of use, transparency for users. Improved security. Low operational overhead. Enable zero trust network access. Enable. Increase effectiveness of network and security staff. Centralized policy with local enforcement. These are the benefits of adopting SASE. And now we are coming to the end of it, where I just said that I'll explain you why secure access privileges, where reduce IT cost and complexity, delivers a great user experience and reduce risk. So let's go one by one. So if you look at the initial solution, then actually you will be able to appreciate that. So with the data spread across cloud applications and SaaS services, and users often working from anywhere, the traditional network-based security model has reached its limits already because of that. And to compensate, organizations have been forced to deploy additional services to fill the gaps in their security. Right? Now, it's actually working on the deployment management, operating cost, and other things. So it's not growing fast enough. Right? So there's going to be need for this actually. The cost, complexity, and network security model, and in this, it cannot scale. It's not agile, and it's simply not effective in the digital world. So Instead of trying to use the legacy concept to solve the modern problem, SASE flips the security model. That's the reason I said it's important to understand the computing paradigm shift and understand edge computing before you look at the SASE model, because it is actually flips the security model. And look at the what I say, security models, different security models, and how it is evolved. It is very interesting to look at it. So while legacy approaches focus on creating perimeters around the application, I just explained you the perimeter also, what is perimeter, and in case of cloud, I explained you that. SASE focuses on the entities such as users that are accessing the application and pushes security as close to the entity as possible. Right? And as a cloud service, SASE dynamically allows or denies connections to the service based on the organization's defined business rules. So it looks at the business rules of an organization before giving access to any user to the any resource. And that should be very clearly mapping, and that mapping is available with SASE. So it's all done through the single service that unifies the number of previously separated functions, what we have listed down 11, SWG, GTNA, and so on. Right? And it delivers a great user experience. So the applications are distributed across multiple clouds, and your method, so you have a less latency here, and your method of accessing this application is still based on the old model of VPN connecting to the network for security. So the SASE calls for security to be enforced close to the user. So intelligently managing user connections at the internet exchanges and optimizing direct connections to cloud applications and services to ensure optimal bandwidth and low latency. And that actually results in the good user experience. Okay. So it comes down to providing optimal bandwidth and lowest latency. The only way to do this efficiency is to reduce hops, because reducing number of hops, as I have explained in case of edge computing, is applicable here. That if you reduce the number of hops, because what your data, what your decisions, if it is taken multiple hops, that much latency is increased. Now, if you want to do it nearby, then actually, as I said, multiple point of presence you require. Like we do a replica in case of content distribution network, right? And this is reduce the hops to get the applications and ensure the right bandwidth is allocated. So even the number of hops and the bandwidth, so these are all very important. The right approach places the security stack as close to the user as possible in the internet exchanges across a widely distributed geographically deployment. And accessing application from these exchanges requires the ability to intelligently route traffic to the application. So even the placement algorithms, even the routing algorithms, all that need to be looked in, which is supports this particular paradigm. So closest geographical location through direct peering. And actually, I will not talk about what to avoid, right? Because it does not scale. So we should not talk about a VM-based solution. So that is what we need to avoid that. Right. So ideally, the offering is cloud native, built on microservices with the ability to scale out as needed. And to minimize latency, packets should be copied into memory, acted upon and forwarded blocked, not passed from virtual machine to virtual machine or from cloud to cloud. Right. So this is what we need to understand, that the software stack should have no specific hardware dependency and to be instantiated when and where needed to deliver the risk optimized and policy-based capabilities to the endpoint identity. Then the third one is that it gives you reduced risks. Security is all about risk identification and avoidance. Right? And SASE as a cloud service is designed to address the unique challenges of risk. And by defining security as a function built into very fabric of the model and not function that's separated from the connectivity of the services, it ensures that all connections are inspected and secured. All connections are inspected and secured, no matter where users are connecting, what apps are accessing, or encrypted, and any encryption that may be used. So another thing in these cases, GTNA is a very important part over here. And GTNA ensures that only users who have authorized to access an application can do so. And this authorization is defined through the business-based policies and not complex multi-layer policy definitions. Right, and this is zero-trust network architecture is key to the risk reduction in the ability of this concept of network-based connectivity. So another thing is that what you look at the topmost statement is that it reduces it removes the attack surface, because the data is not black holing to the respective organization and then coming back. So because it reduces the attack surface, it reduces the risk of attack. Because data in transit model or data in store model security, what you see in what you probably have studied, you will realize that. So less data in transit. So you will have less surface of attack over here. And by hiding the corporate network and source identities from the internet, SASE prevents adversaries from targeting you with attacks such as DDoS. Lastly, the SASE architecture is built with full data context being exchanged between entities and applications to ensure that all connections meet compliances and data governance requirements. So in the interest of time, I'm just giving some few more minutes, and then I think last 10 minutes we can have general discussion. So with this, let me stop here with this last slide, right? So there are something what we need to avoid, but we'll not talk about it right now, and we'll just tell that SASE requires a single pass architecture to process all the content at once, right? And with this, thank you very much for your time and patience.
Guys, if you have any query, you can ask from our professor. You can write in the chat box so that sir can reply to your question.
Or else you can mail it to my email ID also, Rafik, and send them, because they may come across some other queries, and I'll check if I can share some slides to the participants.
Yes, sir, it will be better. It will be better. So guys, you can mail to the sir directly if you have any query related to this.
At 12:30, in fact, I have another meeting with our
sure,
team
sir,
here,
sure,
which
sir.
I already extended.
Sure, sir. Thank you so much, sir, for accepting our invitation. It was really actually nice presentation, and we have enjoyed a lot, and hope so all the participants will get the benefit. Thank you so much. You can leave, sir. No issue.
Thank you very much. Thank you.
Thank you, sir. Thank you. Thank you. Murli, sir, we can end this meeting now. Murli, sir, are you there?
Yes, sir. I'm going to end this meeting, sir.
Okay, okay, sir. Okay, sir. Okay, guys. Thank you so much. Again, we will meet at 3:10.
3:10. Okay, fine.
Thank you, sir. Thank you.